Now, 12,000 liter tank of water, okay, filled to capacity. Model here, this is liters per hour is given by this piecewise of which it's draining. Okay, so from 0 to 5 hours, it drains at a different rate or a different function that describes it as from 5 hours on. Okay, these functions describe those intervals of how the rate at which it's draining. At some point, it will be empty. Now, is R continuous at t equals 5? Show your work that leads to your answer. So to know something's continuous, don't need to know that the limit from both sides is the same. If you read this right here, it's saying it's not continuous because what you'll find out is the values from each side are different. And to be continuous, the limit from both sides should be the same. So this is a very good way to explain it to be continuous, with a very thorough using limits to explain it. There are other ways to explain it, but limits does a good job to explain why it has to connect from the two piecewise. You wouldn't need to use the word limits, but I think it's just nice and neat. Now, for B, find the average rate. Be careful of the word rate. The average rate at which the water is draining from 0 to 8. Now, is this function a rate?
Yes.
So it is a rate already. So I want the average of this function. But it's from 0 to 8, and so this is a little bit tricky. Aren't there two different functions?
Yeah.
So when you look at this problem, what you'll notice is this is what you want. Don't you want the average rate? So that's pretty simple. The question is, but it's two different functions, so you got to be careful to break that into two sets. From 0 to 5, you're using this function. From 5 to 8, you're using this function. And you have 1 over 8. Now, be careful that you don't think, oh, I don't need 1 over 8 here. Some of you might want to put, oh, 1 over 5, and this is 1 over 3, and do each separately. That would not be a good idea. Because the whole thing, you're summing up all of it. See right here? This is what's in the parentheses. It's two functions. And then you're averaging it, dividing by 8, not two separate averages. And then use your calculator to crunch it. So if you can crunch it with your calculator, you're good to go. So just make sure you can crunch it with your calculator. All right, find R prime 3 using units, correct units, explain the meaning in context of the problem. So let's talk about this one. And I need to move it up. Here's what they say. And I kind of like their way of saying it. First of all, R prime 3. Can't you just use your calculator, plug in 3 to the use the derivative function at 3? Now make sure you use on the piecewise, make sure you use the piecewise function from 0 to 3, this function right here. Got it? You got to use that function. If you don't, it's not going to be pretty. Because 3 is from that interval. And so basically you're just plugging in 3 to the derivative of this. Calculator does it. Okay, anyways, I love their description. The rate at which the water is draining, because you went in context of the thing. The word rate here is very important. And this word decreasing is also very important. The rate at time 3 is, you're right, increasing, not decreasing, is increasing because that's a positive 50. And the units are perfect because it's liters per hour, because you derived it, took the derivative of it. So the rate is increasing. The word increasing, doesn't that mean derivative? Instead of saying the rate of the rate, that kind of gets confusing. You could use that. You could say the rate of the rate is positive or is 50 degrees. But I like the word increasing because it explains it's going up versus down, which is an important feature. The last problem, write but do not solve an equation involving the integral to find time A where the amount of water in the tank is 9,000 liters. So it started at 12,000, correct? It wants to know at what time A, some time, it's going to be 9,000. So isn't this asking for amount of water? See the key word, amount of water? So we have to first think of an equation that gives us amount of water. And then we want to find the time. We don't have to solve it, just set it up. And when it equals 9,000. So if I want amount of water, aren't we going to integrate a rate? Correct? You're going to integrate a rate to get amount over an interval. So let's take a look what they do here. What you get here is right there. Do you see how they started at 12,000? They minus the change, the sum of the rate from 0 to A. Because don't know A? Isn't that what they want to know? A right here? A is a time. which would be the interval, at which it equals 9,000. Because don't you want the 12,000 taking away all this to equal 9,000? Now, could you technically solve this? Yes. It'd be kind of ugly. But you could solve for a. You just do a whole bunch of kind of work dealing with integrals and stuff like that. You could solve this, but nicely they don't want that. So this is an amount equation.